Assalamualaikum warahmatullahi wabarakatuh and good afternoon everyone. So today me and my group will be talking about the timber floor system. So my group consists of me, Heba, Asia, Kansa, Anis, Nuha, Kauthar, Ibrahima and Balkis, and together all of us make up 9 people. So these are the things that we'll be talking about today. So we have 10 topics and my group members will be taking turns in talking about each one of the topics. And we will be discussing about the elements of wood, structural elements. So to begin with, what is a floor system? So floor systems are horizontal planes that are there to support life, which are like furnitures, moving people in a building, and dead loads like the construction weight of the floor system itself. And basically what the floor system does is that it acts as a medium to transfer loads horizontally onto either beams, columns, and girders and load-bearing walls, which is why they are situated between beams and girders usually. So there are 3 types of floor system: wood, steel, and concrete. But for today's video, we will be focusing on the wood floor system. The wood floor system has 2 types: wood joist system and wood plank and beam system. So the wood joist system has smaller joists in comparison to the wood plank and beam system, and in addition, they are spaced a lot more closely to each other. And the beams and walls of a wood joist floor system support joist, and the subflooring, which is a flat surface of which every other layer starts on top of, and the underlayment, which is the surface, a consistent and smooth surface for a structure. And the applied ceilings, they are short span, meaning that the intermediate support, let's say like beams, the distance between each intermediate support system like beams, they are a lot shorter. And the wood joist floor system has flexibility in its form and design. And the wood plank and beam system, they require additional framing at the floor openings and at concentrated loads and at places where the loads are concentrated. And if the underside of the construction is exposed, it's kind of hard to like put hidden electrical or mechanical lines underneath because it's exposed. And because it's exposed, the floor system will be less resistant to sound transmission. So wood joists are horizontal structural elements that are usually in between beams so that they can create an open space, and also there to transfer loads onto vertical elements like those beams. And they're also there so that they can make a level working construction platform with its subflooring and sheathing. And if they are properly engineered, they can be structural diaphragm, meaning that they can transfer lateral or horizontal loads onto the shear walls. So this is how joists would look in a structure. So the joists at the end, they are there so that they can add more support for the perimeter wall framing. And to add more support, to add support to that end joist, there are rim joists or header that act as horizontal support for the joist ends. So joist spans, what are they related to? What factors affect the spans? So first, they have 4 factors that can affect the joist spans. So first is the magnitude of loads that are applied onto the joist. And the second one is the joist size and spacing. So whether or not they are spaced closely or far apart from each other, that affect the joist spans. Third is the species and grade of lumber used, and fourth is the deflection allowable for the intended use. So when we talk about wood joists, it's a lot more important for wood joists to be stiff, to have more stiffness than strength, because the stiffness of a wood joist determines how it reacts when it faces stress and how it resists deflection and deformation. So to add stiffness, joists that are deep, they should be spaced apart they should be spaced apart. By deep, I mean they are a lot more thicker in terms of height. And if you were to choose, it's more preferable if you were to choose joists that are deep, that are spaced apart, in comparison to joists that are shallow and are spaced closely. So these are the span ranges that are usually used for wood joists. There are 2 by 6, 2 by 8, 2 by 10, and 2 by 12. The 2 by 6 is up to 10 inches long.
Assalamu alaikum warahmatullahi wabarakatuh. This is Hiba Sarawi, matric number 1914-194. I'll be talking about the wood joist framing. So a wood joist framing is a joist, a horizontal structural member used in framing to span an open space, often between beams, that subsequently transfer loads to vertical members. When incorporated into a floor framing system, joists serve to provide stiffness to the subfloor sheeting, allowing it to function as a horizontal diaphragm. Joists are often doubled or tripled, placed side by side where connections such as where partitions require support. So these are the pictures that represent it. Horizontal or diagonal bridging to prevent internal chords. The relatively lightweight construction is attached to wood joist framing because of their standard depth and manufactured length. Open wet joists should span rectangular panes. The framing works most efficiently when the joists carry uniformly distributed loads. If properly engineered, constructed loads may appear over the pintle points of the joist. Steel joists are laid out and assembled in a manner similar to the wood joist framing. So the joists are spaced usually 16, 24, or 48 inches, depending on the attitude of the appealed loads and spanning capability of the floor depth. Connections are made with a self-drilling, self-tapping screws inserted with an electrical tool. As you can see here in the picture, the plates, anchor, or handholds may be required to secure the walls and floor framing to the foundation against the uplifting wind or forces. So this is all for my part. Next, my friend will be talking. So thank you so much.
Assalamualaikum warahmatullahi wabarakatuh, and I'm Asa Mama Amin. And for my part, I will be discussing about what is wood subflooring. So basically, wood subflooring is a structural material that spans across the floor joist perpendicularly and serves as a working platform during construction and provides a base for the finished flooring. Just now you have understand about wood joists, so let us move on to the subfloor. So before that, floors consist of 4 layers. So basically, first of all, we have the joist. Second, subfloor, a base for the finishing floor. Third is underlayment, and the fourth one is the finished floor. So why do we need subflooring so bad? So first of all, it provides us a support layer for your finished flooring. And the second one, a working platform during construction. And the third one is a structural diaphragm to resist horizontal forces. So typically for wood subflooring, it consists of plywood for the panel, although there are several other options such as oriental standard boards, wafer board, and particle board, which all 3 of them I will show them later. So the span rating is part of the grade stamp found on the back of each panel. So the span can be 24 inch, which is 609.6 millimeters, if the 20 meter wood strip flooring is placed perpendicular to the joist. So as you can see here, these numbers are the span rating placed on the back of the panels. So the first one indicates the first number, such as for example 36, the left side. It indicates the maximum number or the maximum rafter for roof sheathing. And on the right side, the number on the right side indicates the maximum span rating for the wood for the subflooring. What is an underlayment after all? It acts as an impact load resistance. It provides a smooth surface for the direct application of non-structural flooring materials. So when we want to put floor finishes, so we need to have underlayment. and then it functions as a sound barrier, so it really helps reduce the noise, protects us from moisture and heat, and underlayment can be placed separately or combined together in a single thickness with the panel sub. So first of all, this is the Oriental Standard board, OSB, and this is the wafer board, and this is the particle board. So basically the difference between OSB and wafer board is that wafer board is a weaker and less stiff cousin of OSB, yet OSB is engineered to have strength and stiffness equivalent to plywood. And finally, when combining subfloor and underlayment together by gluing them together to the floor joists, it will create an integral T-beam units, so like the one we see in this picture. It will help reduce the floor creeping noise such as squeaking, improve the stiffness, and in certain cases increases the allowed spans for the joist. And all these qualities depend on the quality of the application. And in addition to gluing, the panels are secured with power-driven fasteners or with 6D ring or screw shank nails. So that is all from me for the topic of wood subflooring. Moving on to the next topic.
Assalamu alaikum, my name is Kansa and I will start my part with prefabricated joists and trusses, which is pre-engineered. Wood joists and trusses are increasingly used in the place of dimension lumber to frame floors because they are generally lighter and more dimensionally stable than sawn lumber, are manufactured in greater depth and length and can span longer distance. Here's the I-joists, which are manufactured with sawn or laminated thinner lumber planks along the top and bottom edges of a single plywood or OSB whip. It is the normal type of trusses, which has the normal depth, and it is 10 to 16 and 20 to 60 spans. Here's the other type of the trusses, which they are different in the depth and span, as you can see. What is the rule? The rule of the thumb for estimating depth of a trusses joist: span should be 18 and it should has openings in widths, allowed the passage of electrical and mechanical line. Also consult manufacturer for available length and depth, recommended spacing and allowable spans, and require bearing condition. Here's the I-joists, the detail of it. So why the presses for the prefabricated floor joists or trusses fair with the manufacturer. The way they are laid out to frame a floor is similar in principle to commercial wood joist framing. They are most appropriate for long spans and simple floor plan, but for the complex floor it may be difficult to frame. Here is I-joist at interior, so you can see the two blocking and continuous steel plate, and it is 3.5 minimum bearing. At the interior has a steady bearing wall. The middle one is I-joisted, which must be stiffened under bearing wall. Consult manufacturer and the building code for requirement. Also here the wood panel subflooring with 24 spacing. A trusses joist may bear on top or bottom, either of them. At the top, cord bearing has continuous nailer for lateral support of bottom cord and wood stud. At the interior has wood bearing or stud bearing wall, headers, wall support joist at the opening. Here are the double truss provide support, and the cross one called bracing, which is necessary to provide lateral support to the plan of the chassis. The bottom part of the card has continuous banding here and the wood stud. At the interior one you can see the wood bearing. Also the middle one called support at panel point. Similar to the overhang has also the support at panel point with the continuous banding. Overhang should be engineered by joist or truss manufacturer. That's all from me and thank you.
Hi, my name is Anis and I'm going to continue with wood beam, which is a structural support. It was designed to resist bending when stressed by weight and forces like high wind. They distributed the weight and provide support in structural elements for roof and floor, and types and sizes of the beam determine how much weight a single wood beam will be able to bear with. Okay, so we're going through the types of wood beam, which is the first one is solid sawn lumber. It was available in a variety of species and grades. Consists of two major classes of wood, which is hardwood and softwood. So for hardwood, it's more for furniture, wall paneling, and flooring, and for softwood, it's for general building construction. The next one is glue laminated timber, or we can also call it as glue lam. It was made by laminating stress grade lumber with adhesive under control, with the condition that the grain of all plies being parallel with each other, to make it more strong and also secure. And the advantage of this glue lamp is that it higher load unit stress. It can have a higher load bearing, and it can improve appearance. It was very strong and availability of various sectional shapes, which is it can be factory curve, and also it often used as a ground to ground arches in plank and beam structure, as you can see on the right picture over here. So the next one is parallel strand lumber, or we can call it as PSL. It was made by bonding of long, thin strand of wood under heat and pressure using a waterproof adhesive. It used as beam and column in post and beam construction for beams, header, and intel in light frame construction. It was significant environmental benefit as it was processed using log trees and consistently straight, strong, and resist shrinking, warping, and splitting. As you can see in the picture, at the end of the beam, the pattern of the beam is kind of massive. It was different with next one, which is laminated veneer lumber (LVL). It was made by bonding layer of wood veneer together under heat and pressure using waterproof adhesive, which is grain of all veneer run in the same longitude direction. And this one it is strong when edge loaded as a beam or the face loaded as a plank. Next one is box beam, which is it was made by two or more plywood, or as OSB, Webster sawn, or LVL flange. Not serve to support as a solid beam, but rather to add aesthetic beauty to the room. And it is lightweight, simple to fabricate, conventionally stable, good design, structurally efficient, and economical. The next one is flitch beam. Okay, so this is the combination of a steel plate and two timber being held together with bolts, which is, as you can see in the picture, the black one is the steel plate, and it was sandwiched with two wood timber, and also it was being held with bolts. It is lighter and cheaper than pure steel, also serves as a strong support to building structure. It can be more stronger by adding more timber and steel layer into the design, as you can see from the left picture to the right one. And it is strong yet cost effective as they require a smaller workforce. The next one is space beam. It locked and securely nailed at frequently interval to enable individual member to act as integral unit, and it have higher load bearing capacity of a floor. You can see there is a space between each beam. And the last one is pull-up beam. It was made of individual pieces of lumber that are nailed together, can be 3 or more, and equal in strength to the sum for each individual pieces. They have the equal strength, so it's kind of strong too. And you might be confused about the difference of beam and joist. which is joist and beam. They have many similarities, but they are different in size and the role that they play. As you can see, beam is much more bigger for the size, and joist is smaller. And beam have few number of types, and joist have numerous number. The joist, it was supported by beam, and beam, it was supported by foundation, posts, and walls. And the role of it, that beam, it can carry and distribute the main structural loads of the flooring system down to the post, wall, or column below. And joist is provide secondary support, and it connect to the beam either at the end, sit on the top, or to be attached along the side of the beam. I think that's all for my part. Thank you.
My name is Ainuha binti Adnan, and for my part, I'll be telling you about the wood part. As will be mentioned before, as you've been known from the previous part, the beam is function to transfer load from the floor above to the nearest wall. Okay, so in order for the beam to function well, it needs support for it to support the load itself. Okay. So there's many types of beam support. The first one is the masonry or concrete wall support. Okay, as you can see on the screen, the first one, the masonry concrete wall support. Okay, this is the picture of it. This is the timber beam, and this is the masonry wall or concrete wall. Okay, as you can see, there's steel clip angles are attached on the beams and the wall to hold it on, and there's also an anchor bolt on it to attach on the steel clip angles that been attached to the beam. Okay, so it's like a double attachment, so it's very very support. So the beam will stay in place, and it will be easier for the load to transfer if it's in one place. Okay, as you can see, there's also a minimum space, a small space between it, because the small space is to provide resistance up in horizontal force. As we all know, there's a force from the wind. If the wind is too strong, there's a chance for the building to move, right? So these spaces are needed in case the wind are too strong and the building moves. So there's a chance for the beam to hit on the wall. There's also a risk for the structure to broke if it hit the wall. So it will crack on the wall. It's something that we do not want. Okay. So there's also an optional for the prefabricated beam seat on the beam seat for where you want to put the beam. For the second one is the foundation wall support. Okay, as you can see the picture here, this is the beam, and then there's a steel plate underneath it working as a foundation for the beam itself. And then there's also another work as a wall for the beam. Okay, for the wall, it is very recommended to use that has the same depth as the beam. Okay, so it's better for you to have the same depth. Okay, there's also a minimum bearing upon the steel plate, as it helps to in case if there is no minimum bearing on the steel plate, there's a load hitting on it, is very very chance for the beam fall straight down. So there's the minimum bearing upon the plate is very very needed. So the load that been transferred can be able to move here. Okay, because something is holding on to it. Okay. But this foundation wall support is it's only being recommended for the light construction, because it's not very depending on the masonry and concrete wall just now. This one they have the attachment and all, so it's very strong. But this one is not suitable for the heavy construction. Okay, and then the next one is the girder support. Okay, the girder support, there's two types. There's light to moderate load. Okay, and then the second one is the moderate to heavy load. Okay, the first one, this is the light to moderate load, and then there's a moderate to heavy load. As you can see, for the light to moderate load, there's putting the girder here. This is also called girder. This is the how it looks like in real life. Okay, and then there's also a metal tension tie across it for it holds on the beam. So for the moderate to heavy load, there's laminating all the surface of the beam. On the other, there's this beam, and this is also a beam. So it's this girder, there's full coverage on all of it. There's like one here, another one here, and then another one on this side. So it's very very full coverage. So that's why it's for the moderate to heavy load. But the next one is for the in case you have used a long or continuous spans of types of beam. So like more uniform stress are being put on the beam. So as you can see, the load is here. So it's very very stressed on the beam on this on the middle part, right? Any splash should occur at points of minimum bending stress. So it's like there's might be a crack here, maybe here. So there's a chance for it to happen. So in order for it needs to add support to hold it on. Okay, it's like this is the beam. Okay, this is the picture, and you put a support here, and a support here. It's very helpful. The stress from here will be like the positive bend and the support. The load. Okay, the load will be hitting on here this part. So if it doesn't go straight down, it's like a wavy type. And then there's like two ways to help this case. The first one is the mortar splice, where you cut in this part, this one. So it will help. Like if the load is being hitting here, either have to push through it. You like to push through it. So if it wants to crack, so it's very very good. If you want to just this way, and then the other way is the steel splice connector, where you attach you sandwich it with like a steel fish plate, and then there's like connector attached on the beam, so you will not got separated if there's a load on it.
I'm Kausa, and now I'm going to present about wood post beam connection. The size and number of bolts required at connection depend on the thickness of the members or the wood, the species of the wood, the use of metal connectors, and the magnitude of and direction of the load relative to the grain of the wood. What is wood grain? Wood grain is the longitudinal arrangement of wood fibers or the wood pattern. As you can see in the picture, there are many types of wood grain. Shear plate or split ring connectors, you can see in the picture, which can develop greater stresses per unit bearing, can be used when there is insufficient area to accommodate the required number of true bolts. This is true bolt. We also include a YouTube link on shear plate installation in the description. So the first wood post beam connection is exposed column cap. So this we use steel U plate. It has welded connection to the steel post, and this is the side plate for connection to wood post. And to stick them together, we use through bolts. And this is the clearer picture of the steel U plate. The second one is exposed T strap. This is the exposed T strap. For this, we use 6-inch minimum bearing in direction of beam span when two beams abut over support. So you can see there is two different beams here, and so if there is two beams, we must use at least minimum bearing of 6-inch. Bearing length is the length along the steel plate on the beam. Beam span is the length of the opening, the other beam. The next one is continuous post. This is the continuous post. So this block is the blocking. We use blocking as required. This is the through post or split ring connector, and this is the spaced beam where there is two different separated beams here. So it is called spaced beam. And the thing under it, bearing blocks, we use bearing block that provide direct support and increases area for bolts, because sometimes the bolts are long. The second one is next one is also continuous post. So to join the continuous post and separated beam together, we use steel clip angles, metal strap tie, and steel brackets with web stiffeners and through bolts. Web stiffeners is the thing here the right angle triangle here. The next one is continuous beam. As you can see, for this one, the beam is continuous and the post is separated. So to join them together, we use metal strap tie, and inside the wood we have shear plates and pins, and under it we use bearing blocks that provide direct support and increases area for both. Next one is space post. As you can see, there is two different posts, and there is blocking at top and the bottom in between the posts. And this is the continuous beam, and we stick them together using through bolts or split ring connector. Okay, the next one is concealed connection. So inside the wood, we insert steel plate in sawn curve. Curve is used to describe the thickness of the cut that a woodworking saw blade makes in a piece of wood as it cuts through it. So when we cut through it, we insert the steel plate. And also we use steel pipe with bearing plate if necessary. For concealment, we contouring bolt heads and nuts and plugs. Last one is interlocking connection. There is through bolts or split ring connector here, and inside, as you can see, this is the continuous middle post member, and this is the beam. For the beam, we have the continuous outer beam member. The inside is separated. That is interlocking connection. So that's all from me.
So first, let's define what is a wood plank. The wood plank is timber that is flat, elongated, and rectangular. The parallel faces that are higher and longer than wide, as you can see on the picture just here. Used primarily in carpentry, planks are critical in the construction of ships, houses, bridges, and many other structures. Planks also serve as supports to form shelves and tables. So now, let's move on to the constitution and the use of wood plank. Usually, the wood plank is made from saw timber. Planks are usually more than 38 mm thick and are generally wider than 64 mm. In the United States, planks can be any length and are generally a minimum of 51 mm deep by 200 mm wide. But planks that are 51 mm in 250 mm and 51 mm by 300 mm are more commonly stocked by lumber retailers. Planks are often used as a work surface on elevated scaffolding and need to be wide enough to provide strength without breaking when well done. The wood is categorized as a board if its width is less than 64 mm and its thickness is less than 38 mm. Plank used in building as horizontal supporting members that holds between foundations, walls, or beams to support the sailing of floor is called a joist. The plank was the basis of maritime transport. Wood floats on water, and abundant forests meant with them logs could be easily obtained and processed, making planks the primary material in shipbuilding. However, since the 20th century, wood has largely been supplanted in ship construction by iron and steel to decrease cost and improve durability. And now, let's explain the image just right here. So, just at the top, you can see the structural floor plan of wood decking. Here, the wood beams may be supported by timber, steel, or concrete columns, timbers or steel girders, like here, concrete or masonry bearing walls. Bearing area should be sufficient to ensure the allowable compressive stresses of the beam and bearing material are not exceeded. So the wood plank and beam floor system are typically used with a supporting grid of posts or column to form a skeleton frame structure structure using larger but fewer structural members that can span greater distances translates into potential savings in material and labor costs. And just for this image, we can see just right here, this is the primary beam, and then the secondary beams here, and the secondary beams may span over or frame into primary beams to reduce span of decking. This is the beam spacing, like the distance between the two beams. So the span of planks or decking is from 4 to 8 inches, and plank and beam framing is most effective when supporting moderate, evenly distributed loads. Concentrated loads may require additional framing when the structural system is left exposed, as is often the case. Careful attention must be paid to the species and grade of wood used. The detailing of joints, especially at beam to beam and beam to post connection, the quality of workmanship. Plank and beam framing may qualify as heavy timber construction if the structure is supported by non-combustible, fire-resistive exterior walls, and the members and decking meet the minimum size requirements specified in the building code. The disadvantages of the plank and beam floor system include its accessibility to impact sound transmission and its inherent lack of concealed spaces for thermal insulation, piping, wiring, and ductwork. So just right here is the opening, and concentrated loads require additional framing, and the diagonal bracing or shield walls that require to provide lateral stability. And now let's move on. So there are the wood strip flooring that laid at right angles to planking, and here the wood studs, and just below the sole pad, and at the down part, this is the load of non-bearing partitions. Perpendicular to the floor decking is distributed evenly across the planks. So there are the partitions parallel with the floor decking, may be supported either below or above the planking, and this is the beam, must be framed into posts or other beams for support, limited overhangs possible. In the plank and beam framing system, the supporting grid of beam should be carefully integrated with the required placement of interior partitions for both structural and visual reasons. Normally, most partitions in this system are non-load bearing and may be placed as shown. If bearing partitions are required, however, they should continue down to a foundation wall or be placed directly over beams large enough to carry the imposed load. Now let's move on to the last part. At the top, this is the combined subfloor underlayment with a thickness of 29 mm, and here this is the tongue and groove edges, and here, like the distance between the two wood plank, this is the can span up to 4 inches. And now at the top here, this is the straight skin panel consists of plywood facing bonded with adhesives underhead and pressure to lumber. And just at the bottom, this is the stringers and cross bracing. The plywood facing and lumber stringers act as a series of items with the plywood distributing concentrated loads and resisting nearly all of the bending stresses. The panels integrate thermal insulation, vapor retarder, and interior finish into a single component, and the limited overhangs possible. So now that's all from my part. Thank you for listening to me.
Assalamualaikum, I'm Balkis and I'll be explaining on the topic of wood decking. So what is wood decking? Deck is a flat surface that is similar to floor but usually constructed outdoors. Most of the time decks are elevated from the ground and also connected to a building. So what are the functions of decks? Decks are part of garden landscaping. It is also used to extend the spacing of a building and to create outdoor spaces. Okay. Next is the types of wood decking. There is 3 main types here. The first one is solid 2x6 or 2x8 nominal. You can see there's one connection in the middle of the woods, in the middle of the planks. So that is what differentiates the first type with the second type. The second type, solid 3x6 or 4x6 nominal. This second type have 2 connections in the middle, so it's bigger and it's tougher. And the third type is laminated. You can see the difference between the 3. The laminated is quite different shape with the first and the second one. Okay, so next, the surface pattern for exposed ceilings. Here there is 4 patterns. For this is like decks, high-rise decks. This is for high-rise decks where there is another level underneath it where we can walk or we can sit or we can do activities underneath. So we can see the exposed ceilings. The first pattern is V groove. You can see here the V shape, so that is why it is called V groove. Okay, the second one is the channel groove. You can see, but it's not really C shaped, but it's like C. And the third one is plain or molded spline. The left one is a plain spline, the right one is a molded spline. The difference is the molded spline is like curved. There's like curved shape in the middle. So and the fourth one is straighted. Straighted is like mini channel groove, but the difference is like straighted because of it's small and it's more tightly together. It creates more texture to the ceiling. Next, types of spans. There is 3 general types of spans. The first one is simple span, double span, and contiguous span. The simple span, here is the picture. You can see that planks are supported at each end. So there's like 2 ends. So the planks are only supported at the 2 ends. So because of this type of span have the most deflection because there is no support in the middle. Okay, for the next one is double span. Double span, you can see the difference. It's like major difference between the first type is there's a middle support. So it is stronger than the first span, the simple span, and thus it is the most efficient structural use of material of given length. The third one is contiguous span. Planks span continuously over 4 or more supports. So this type of span can have more supports. And you can see here the planks or the woods are all at different and random length. So this, its benefit is like it can reduce waste. You can use like leftover woods from any construction, so that woods can be used in this type of span to avoid wastage. And also in this type, the layout of the decking must be controlled. Why? Because the planning will determine the number of support needed underneath. So that is all for wood decking. For conclusion, we can summarize what is floor system and the functions. Floor system is the base support for the loads of a structure, and there is 3 main divisions of floor system according to materials, which is firstly wood, steel, and also concrete. And we also understand
that a floor system is connected but is different from finishes of flooring. You can also see that there is two main types of wood floor system. The first is wood joist system and the second is wood plank and beam system. Both of the systems have their distinctive qualities and characteristics to suit the nature and the situations of usage. Joist systems are normally for residential structures and when flexibility is needed more, while plank and beam systems are more for commercial buildings where more structural strength are needed. There is a difference in the way of constructing and projecting both of the types as explained by the previous members. So to decide on which one to use, which type of system to choose, it is according to the situation and also the type of structure to be built. So thank you. That is all from us. We hope you enjoy and understand the presentation. Assalamualaikum warahmatullahi wabarakatuh.